Hi, today our lesson is about inscribed angles in a circle. So an inscribed angle is any angle who has a vertex on the circle. So the sides have to be chords, and the vertex, remember that's the point of the angle, the corner, has to be on the circle. So we've been talking about the central angle. So if I'm going to stretch this rubber band to the central angle goes to the center. But an inscribed angle takes that angle all the way across the circle to the other side. Now, something that we know already is that if this arc is 50 degrees, then the central angle is also 50 degrees. Okay, so we know that center is same. But what happens with an inscribed angle is that when you pull it all the way to the other side, of the circle, it stretches to half of the angle measure. So the center is the same, that would be 50 degrees. And if you go across to the other side, it's only 25 degrees. Okay, so this angle that cuts off arc AC would mean that angle, if the arc is 50 degrees and we take half of 50 degrees, then the angle measure would have to be 25 degrees. So the measure of angle AMC is 25 degrees. Now, there's one other cool thing that happens with this, is that as long as we are cutting off this same arc, it doesn't matter where this angle touches the circle. So if this is 25 degrees, even if I pull it over here, it's 25 degrees, or here, or if we go all the way over to the other side, it's 25 degrees. Even if I come way up here, this angle is 25 degrees, as long as it cuts off that same arc. So even if I had this angle way over here, okay, if this angle cuts off, if it intercepts that arc, then it's also 25 degrees. Okay? All right, so let's use that for our circles. Okay, here's an example where we are supposed to find the measure of angle A, but they only give us arc measures. Okay, so we're going to have to work our picture and use everything that we know. For example, we know that the total arc measure is 360 degrees in a circle. So if you look at this, you need to think, how can I get this angle? I don't have any other angles. I don't have a central angle. I don't have a triangle. But we do know that this arc goes with this angle. So angle KAY intercepts arc KY. So if only we could find the measure of arc KY. Well, we've got all of this, which we could add that up and subtract it from 360 to get the rest of it. So if we have 360, and we do subtract 60 and minus 160, we should find out that this arc is 140 degrees. Now remember, if we were going to the center of the circle, it would be the same measure. So if this is 140, this is 140. But we're not. We're going all the way across the circle. So an inscribed circle is half. If this is 140 degrees, then by the time we get over here, it's only 70 degrees. Okay, so we've solved that circle. Note, here's something. Segment KA is not a diameter. So just take a look there. Even though this cuts across here, it's not cutting through the center of the circle. So you can't look at that and be like, oh, that's supposed to be 180. It's not. So be careful about that when you look at your circles. Like this plus this is 200, not 180, because it's more than halfway around the circle. Okay. All right. Let's look at this one. All right. So circle G, that means G is the center. If I have to find all the angle measures and all the arc measures, we're just going to have to work your picture. You take everything you have and you figure out how you can use it. For example, if you've got 40 degrees, how can I use that? Well, center is same, so that arc is also 40 degrees. We notice that this is 100 degrees right here. Center is same, so that's also 100 degrees. Okay. Do you remember vertical angles? These angles inside here? Yep, even in circles. So if that's 40 degrees straight across, we have congruent angles. That would be 40 degrees. And then you might think, geez, I'm stuck. How do we know what's left here for this minor arc? Do you see it? If that's a diameter, this has to be 180 and that has to be 180. Okay, so if this is 40 degrees, this is 140 degrees, and this would be 140 degrees. If this is 100 degrees and that's 40 degrees, then we would do 180 minus 100 minus 40 and find out that this has to be 40 degrees. And so that's 40 degrees. Okay, so you just have to get used to working your pictures. Take your angles inside, outside, work them around the circle. All right. Oh, let's throw one of these in there. There's no inscribed angles here. They were all central angles. But let's draw one in. If I take this and I draw that angle to the side of the circle, I know that too because this is 100 degrees, and if you cut that in half, so this is where you go to half, you find out that this is 50 degrees. So that's where you have to look for an inscribed angle. Okay, one more. Let's look at this one. So up here it says that segment AB is a diameter. Okay. We've got circle P here, and we're going to find especially these angle measurements here. All right, so when you look at this, you might be starting with angle 1, but that's not how it works. You have to work your picture, label everything you can, use what you are given. So right away, if you see that 70 degrees, you can use that there because you know that center is same as the arc. Okay. We have 130 degrees here, and if you're looking for an angle from, let's see, using B and D for that 130 degrees, I'm not seeing one. There's no angle that goes to the center, and there's no angle that goes all the way across. But remember that this is a diameter. So if this is 130 degrees, the other side has to be 50 because it has to total to 180. So the same thing here. If this is 70, this would be 110. Okay, so now we can take that to the outside edge of the circle. That's 110. All right. Now you look at it and you see what else can we do? How are we going to get some of these angles that are on the circle? I'll take a look at angle 4. If I trace angle 4, it intercepts arc AD. If arc AD is 50, then by the time we get across the circle, this is only 25 degrees. It goes to half. Now look at angle 3. It also goes with the same arc. So this is 25 degrees. Okay. If you look at angle 2 right here, angle 2 goes from C to B. So it would be half of this arc. So half of 110, we're looking at 55 degrees. Okay. And then this whole angle right here has endpoints on the diameter. If the endpoints of your angle, if the chords of your angle are on the diameter, okay, if the sides go through the endpoints of the diameter, then it's guaranteed to be 90 degrees because this would be 180, half of that would be 90. Okay, so now we're down to angle 1 here. If this is 90 minus 55, that can help us get this angle. So what would be 35 there? Okay. And then we can use that 35 in this triangle. Or we can look at the 70 and say half of 70 was 35, okay? Also, angle 1 cuts off this 110, all right? So that would be 55. So there's all sorts of ways to work your triangles, work your circles, work your angles, okay? Good luck.